Yes, welcome back, dear students. Uh, Today we are going to discuss the next section in Module 3, that is 2.3, on which is on sensors and actuators. In the previous class, we understood memory, different types of read-only memories and different types of random access memory, and how a memory cell is implemented inside the static RAM. In the previous class, you people understood to implement one single memory cell in a static RAM. You require six MOSFETs. Four MOSFETs are used to form a latch or a flip-flap, which are going to store either 0 or 1, and two MOSFETs are used in order to control the access to the memory cell, and they are called as, those two MOSFETs are called as access MOSFETs. I simplified, I explained the operation with a simplified diagram. That means the simple latch with two inverters connected in a feedback fashion in a loop. You understood the memories, and now we are discussing the next chapter, sensors and actuators. So even earlier I also explained you about the sensors and actuators. Sensors are connected to the input ports of the embedded devices, and actuators are connected to the output ports of the embedded devices. Now what sensors basically do, they sense the data from the physical environment, and they give the data which is in the analog format to the embedded system. The necessary conversion will happen from the analog data to the digital data, and then the embedded system processes the data, and after the controllers of the processor inside the embedded system processes, and then the output is given to the actuators which are connected to the output ports, and the actuators are going to convert it into the action, or they are going to drive the external components based on the processing that is done by the processor or the controller. So this is what we are going to discuss for today's session, that is sensors and actuators. Yeah, this embedded system is in constant interaction with the real world. If you want to make the embedded system in constant interaction with the real world, we require the sensors. So the change in the system environment or the variables is detected by the sensors connected to the input ports of the embedded system. This is what I mentioned. So the changes that are happening in the real world, you can be sensed by using the sensors, and these sensors, we have them connected to the input ports of the embedded system. Now embedded system, using the sensors, it will know what's happening in the real world, and that data is given to the embedded system. Now what is basically a sensor? Sensor is a device that converts energy from one form to the another form for any measurement or control purpose. Now we have many different types of sensors which will sense the data, and they are going to convert it from one form to the another form, which is basically used for measuring or controlling purpose. I have two examples here. The sensors, and this sensor most of you are aware of. One is pedometer functionality. So this sensor is available in most of the smartphones, and which is used to count the steps taken. This is one sensor. And similarly there is one more sensor which senses the light intensity. So that is ALS, ambient light sensor. Now this senses the intensity of the light and converts it from one form to the another form, and gives it to the processors or the controllers inside the embedded system. And so this processor or controller uses this data, processes something, and again gives the output to the actuators which are connected to the output ports. Now, the embedded systems, and in the previous class we also understood embedded systems are designed to serve many purposes. Now, in that we understood the embedded system that are designed for controlling purpose, also embedded system that are designed for monitoring purpose also. So the embedded systems which are designed for monitoring purpose will not change the states of the variables. So they just monitor the states of the variable and give the output to the users. But the embedded systems which are designed for controlling purpose, they monitor the states of the variable, and they also have the capability to change the variable state. And it is achieved through an activator connected to the output port of the embedded system. The system which is designed for controlling purpose will produce some changes in the controlling variable to bring the controlled variable to a desired value, and this is achieved through the actuators which are connected to the output ports of the embedded system. Now here the actual definition of the actuator you can find. It's a form of design, again a device which is either a mechanical or electrical device which converts a signal to corresponding physical action. So this is an actuator. Actuator is an output device actually, which is basically connected to the output ports of the embedded system. Now here I have an example. The smart watches use this ALS sensor, ambient light sensor, in order to detect the surrounding light intensity, and uses an electrical or electronic actuator circuit to adjust the screen brightness. Okay, so the electrical or electronic actuator circuit will adjust the screen brightness based on the light intensity which is detected by the ambient light sensor. So the screen brightness is adjusted accordingly. So that is what is the actuator is. Now it is not only sensing the light intensity, but based on the light intensity it is also modifying or controlling the variable in order to adjust the screen brightness. Now I have one more example shown here pictorially. So we have a temperature sensor which detects the heat, and then this temperature sensor, after detecting the temperature, it is sending the signal to the control center. The control center again sends the command to the sprinkler. This is the sprinkler. The sprinkler is turned on, and which is going to put the water on the flame. Now and this is something like, so this is the sensor, this is the control sensor, and this is the actuator. Now what's happening? Now it's sensing the temperature, and then after sensing the temperature, it is also making some physical action. What is that physical action? As turning the sprinkler on, and that is going to put the water on and the flame. Now the actuator. Now you understood the sensors are connected to the input ports of the embedded system, and the actuators are connected to the output ports of the embedded system, which will convert the signal to the corresponding physical action. Yeah, and in this example we understood the embedded system which is designed for controlling purpose. In the next slide we are discussing an embedded system which is designed for only monitoring purpose. Now in the last class also, previous classes also, we understood ECG machine as the best example for the embedded system that is designed for the monitoring purpose. Now here ECG machine, it will go for monitoring the heartbeat of the patient, and using the different electrode sets which are connected to the body of the patient. So it will monitor the heartbeat, but it doesn't have the capability to control the heartbeat of the patient. Now this is the best example for ECG machine is the best example for the embedded system that is designed only for monitoring purpose. So now these are the differences between the sensors and the actuators. Now sensor is an input device, whereas an actuator, as I already told, it's an output device connected to the output ports of the embedded system. Now second difference is that Now sensors, they'll convert the physical parameter to an electrical output. So temperature sensor, it is a physical parameter, and that physical parameter is converted into an electrical output. And similarly, what an actuator does, it does the opposite. It converts an electrical signal into a physical output. So just as we understood in the previous example, now we have here the light intensity is once it is converted into an electrical signal, we have the actuator converting, adjusting the screen brightness, and similarly the sprinklers turning on is again a physical action. Now this converts the physical parameter to electrical output, whereas actuator convert the electrical signal into physical output. Now and sensor, what it does, it detects the events or the changes in the environment and sends the information to another electronic device. Now actuators are the component of a machine that is responsible for moving or controlling a mechanism. They basically do some physical action, hence we say it's a component of the machine and that is responsible for moving or controlling mechanism. Now sensors help to monitor the changes in the environment, and actuator helps to control the environment. So they monitor by sensing the physical environment. Sensors monitor by sensing the changes in the physical environment, whereas the actuator help in controlling the environment. So these are the basic differences between the sensors and the actuators. Now IO system, subsystem. Again, this is one more part of the embedded system, which is necessary for making the embedded system to communicate with the external world or interact with the external world. Now, as mentioned earlier, the interaction happens through the sensors and the actuator connected to the input and the output ports of the embedded system. So this is what is IO subsystem. Next is light emitting diode. We understood in general the sensors and the actuators. So now light emitting diode, LED, is again one important actuator. Is an output device. When I say output device, it is an actuator for visual indication, which is connected to the embedded system. Now generally LED is used for providing the indication to the user. Now, for example, we use LED for giving an indication to the user when the device is on, when the device is off, battery goes low, and charging of the battery. So just to give all these indications to the user, so LED is used. And LED is one output device or one actuator. Now light emitting, so we are going to understand few basics with respect to the light emitting diode, which is LED. Now it is a PN junction diode. It contains an anode and a cathode. So you can see the diagram here. So one is anode, the larger one is anode, and the smaller one is cathode. It is a PN junction diode which is having two terminals. One is anode and other one is the cathode. How to distinguish anode and cathode? So the larger terminal is the anode and the shorter terminal is the cathode. Now anode is always connected to the positive terminal of the supply voltage. You can observe here, so this is the anode which is connected to the positive terminal, and the cathode is always connected to the negative terminal or the ground. And a resistor is also used in order to between the power supply and the LED to limit the current flow through LED. And this is the pictorial representation, the diagram LED. This is anode and this is the cathode, and the anode is connected to VCC, and there is a resistor also just to limit the current flow to the LED, and we have the cathode connected to the ground. Now, and LED can be interfaced to the port pins of a processor or a controller in two ways. One is this: anode is directly connected to the port pin, and the port pin drives the LED. Now we can have this anode pin directly connected to the port pin of the processor or the controller. Now we have the port pin directly driving the LED. If the port pin is at a logic high state, then we say it is logic 1. If the port pin is at the logic low state, then we say it is 0, logic 0. And similarly, now if the cathode of the LED is connected to the port pin, instead of this anode, if we are connecting the cathode directly to the port pin. So and the anode is connected to the voltage. Then LED is turned on when the port pin logic is 0. Now if instead of connecting the anode terminal of the LED to the port pin, if we connect the cathode terminal of the LED to the port pin, if the port pin is logic 0, logic low, then we have this glowing, LED glows. And similarly, if the anode of the LED is connected directly to the port pin, then if the port pin is high, then the LED glows. If the port pin is low, the LED goes off. So if the cathode is connected to the port pin, if the port pin is low, then the LED glows. If the port pin is 0, then the LED glows, and if the port pin is 1, then the LED goes off. This is with respect to the cathode directly connected to the port pin. If anode is directly connected to the port pin, if the port pin is 1, LED glows. If the port pin is 0, LED goes off. So this is one actuator that you understood, that is light emitting diode, and the next actuator is the 7-segment display. So the output device, 7-segment, that is 7-segment light emitting diode display is an output device again, and using this you can go for displaying alphanumeric characters. So you already know this because you used in the previous semester while doing the experiments of electronic circuits. Now it's called as 7-segment LED display, but strictly speaking there are 8 light emitting diodes inside it. Now they are arranged like this. So 8 7. So out of this 8, 7 are used for displaying the alphanumeric character and 1 for representing the decimal point. Now if you look into this diagram, now here you have 7 segments, 7 light emitting diode segments, and this is for displaying the decimal point. Including this, there are totally 8 LEDs. Now you can count from here: 1, 2, 3, 4, 5, 6, 7, and including this it is 8. Now and these 7 segments are numbered, named from A to G. Now how they are named? Like this: A, B. You have to come in the clockwise direction: A, B, C, D, E, F, G, and this is H. Sometimes we give the name H, or you can also call it as DP, decimal point. Yeah, and for displaying 3, say for example I want to display the digit 3 on the 7-segment display. Now which are the segments, LED segment that should be glowing, or which are the 7 segments that should be lit? Now this A, B, G, C and D. That is what A, B, C, D, G. A, B, C, D and G. If these segments are lit, it displays the digital number 3 on the 7-segment. Yeah, and again this 7-segment LED display is again available in 2 different configurations. One is common anode and another one is common cathode. Now these are the 8 LEDs: 1, 2, 3, 4, 5, 6, 7, 8. Now if all the, so this is the positive terminal, anode terminal, and this is the cathode terminal. If all the anode terminals are connected together, connected as a common, then we call it as common anode configuration. And similarly you have one more configuration, that is common cathode. If all the cathode terminals are connected together, then we say it as common cathode. Now if it is a common anode configuration, if I want to make an LED to glow, I have to give 1. I have to give the value 1. If I give 1 to this, then this glows. Now similarly in a common cathode, I have to give 0. 0 means glow in common cathode. In common anode, 1 means glow. Now there is another output device which is an optocoupler, which is basically used in order to separate 2 parts of the circuit or isolate 2 parts of the circuit. Now an optocoupler combines two things. One is it has an LED, you can observe here, and it has a phototransistor also. So LED and a phototransistor. LED emits the light, and we have the photosensor absorbing it. And you'll find this both LED and photosensors in a single package. So both, and this is the example for the photo optocoupler PC817. Now, why we use this in electronic circuits? Why an optocoupler is used in electronic circuits? Because it suppresses the interference in data communication. Now, as I told, it's basically used for isolating two parts of the circuit. Now, why you need to isolate two parts of the circuit? Just to minimize the interference when the data communication is happening. So if the signals are, if I just want to suppress the signals interference from one circuit to the another circuit, I can use an optocoupler between those two circuits. Then you can suppress the interference in the data communication, and circuit isolation you can do, high voltage separations you can do, simultaneous separation and signal intensification can also be done. Now, optocoupler can also be used in either input circuits or in the output circuits. I have the example here. So this is my controller, which has an input circuit and which has an output circuit. See here, I'm using one optocoupler in order to separate the input circuit with the microcontroller, and one more optocoupler for separating the microcontroller from the output interface circuit. Now with this, you can go for avoiding most of the data communication interference, and the circuits are isolated. Now we don't have this the signals here getting interfere with the signals which are there at the input layer. Now the input circuit is connected to the microcontroller through an optocoupler. Now it gets the data from the input circuits. The LED here emits the signals, and we have the photosensor which absorbs those and gives it to the microcontroller. That means we don't have the microcontroller directly connected with the input circuit. Instead, we have an optocoupler, and this optocoupler is used to suppress most of the interference, signal interference, which may lead to the disturbance. And similarly, one more optocoupler, so for connecting the output circuit to the microcontroller. And one optocoupler which is available is MCT2M, which is the commercially available optocoupler. So next output device is a stepper motor. It is again an electromechanical device which generates a discrete motion in response to the electrical signals which are supplied by the processor or the microcontroller. Now you can drive the stepper motor, or you can control the stepper motor. How to drive the stepper motor or control the stepper motor we'll understand in a short while with the working example. Stepper motors are widely used, it is widely used in majority of the industrial embedded applications, and I told it's used in the robotic control systems also. It is used inside the printers because the printer, inside the printer, the cartridge will move from left to right or right to left, so that is again controlled by the stepper motor. So it is used inside the fax machines, and even it does, you'll find a small stepper motor inside the CD drive or inside the DVD drive also. Now again, based on the coil winding arrangement, two-phase stepper motor is classified into unipolar and bipolar. The unipolar stepper motor contains two windings per phase, and you can make the stepper motor rotate either in clockwise or anti-clockwise by changing the flow, by changing the direction of current flow. And when I say unipolar, now it has four coils A, B, C, and D. You can see here coil A, B, C, and D. So rotor, this is the rotor, and this is the stator part. So what do you mean by stator? So this is not going to rotate. Only this is going to rotate based on how you're going to energize this stator. Now when it's a unipolar, it has these many poles A, B, C and D. Now coil A and C carry the current in the opposite direction for phase 1, and similarly coil B and D, they carry the current in opposite direction for phase 2. I'll explain the working of this in the next slide. Now a bipolar stepper motor contains only a single winding per phase. Now the unipolar, they contain 2 windings per phase, but this bipolar, they contain only single winding per phase. Now if I write the diagram for the bipolar, similar diagram, you won't be having 2 coils like this. You'll be having only one coil here and one coil here. Yeah. Now this is the stepper motor working. So this looks little different from this. I have written it as per my convenience in order to explain the working properly. Now you can observe here the stepper motor has 4 poles, or this is the outer part. What you're saying, this is the stator. I have written here stator, and the inner part is the rotor. This is the one which rotates. Now here I have 4 poles, A, B, C and D, and these poles, say if I want to rotate, make this rotor rotate, now I got to energize the opposite poles. If I energize, I have to energize A and C, and next I should go for energizing B and D. Now observe, now on this pole there is a winding, so the wire which is coiled over this pole. Now how the windings are made, and if I look into A and C, the windings are in opposite direction. You can just observe here. So the